Okay, so it seems like we are all here. Thank you everyone for showing up, and welcome to this information session about the Moon Village Association Payload Project and our involvement in it. My name is David Rodríguez. I'm a system engineer at EPFL Space Center, and this is the agenda I've prepared for today. I will start by talking briefly about our new Lunar Research and Technology Development Initiative. This is something that we launched at the end of last year. So I'll present a bit what our goal is, what our vision is, and how you can get involved. Then I'll move on to talk about the Moon Village Association and its payload project. And this is a nice segue to explain their first mission, and our involvement in this first mission with the development of this lunar camera. Unfortunately, Marco from the MVA couldn't make it today, so I'll be introducing a bit the MVA, and then we'll have also Minglu, a PhD student from the Advanced Quantum Architecture Lab, presenting us the technology he's working on for the camera. And yeah, at the very end, we'll have plenty of time for Q&A and an open discussion, which is the part that I'm really interested in. So, as I said, I joined the team I joined the EPFL and the team at the Space Center in October 2020, and already they were having discussions about getting more involved in lunar activities. So for the past 5, 6, 7 years, we've been seeing this rise in interest on anything and everything that has to do with the moon, both from government and particularly from industry. And there is an opportunity, almost we have a responsibility as a top-tier university to do our part in promoting, facilitating, enabling those activities. So that's the basics behind this initiative. So our goal really, at least at the beginning of this initiative, is to be part of the team that designs, develops, and launches a EPFL's first lunar payload. So what we want to see, it's a team of people within the university taking part on an upcoming lunar mission with our own scientific instrument. That's what we want to make happen. But our vision goes a bit beyond that. So what we want to do with this Lunar Research and Technology Development Initiative is to create a framework to enable and facilitate more activities at EPFL that have to do with the moon. So some of my time has been used to identify needs and opportunities within current lunar exploration and technology development roadmaps. And my idea is to bring those back to EPFL, talk to professors and scientists and researchers, and discuss with them what can be done, right? Also providing our own set of expertise at eSpace. What can we do together? And whether there is something interesting that we can be part of there. And also this involves research activities, but also involves education activities with more programs, or more involvement in programs. So yeah, feel free to check the website, get in contact with me if you have any questions about what can we do with this initiative. Just to provide you a bit of an overview of some of the activities that we are trying to kickstart so far as part of this vision for this Lunar Research and Technology Development Initiative. We have a few proposals that we've submitted already related to in-orbit teleoperation of robotic assets on the surface of the moon. We have students that will be working on developing technology and concept design of missions and technology for the exploration of extreme environments like lunar lava tubes. We are also part of a group called GEXLA of the Moon Village Association. It's a group of experts on sustainable lunar activities. So also in policy making, we're trying to have our say, or at least be part of the conversation. And plenty of other activities. We are also trying to be more part of the educational programs at EPFL by suggesting projects for students to do. Some of the courses that are running have, half of the credits belong to hands-on projects that the students can do. So if you are a professor and you have a course like that, where half of the credits or part of the credits are belong to a project that the students need to do, and if they're interested in coming up with an idea that is related to the moon, just get in contact with us. And we have plenty of ideas in our pipeline that we can suggest you do, or that your students can do, and we can go there and present it to them. So the value proposition of this initiative is, again, identify what needs to be done. What are the knowledge and technology gaps currently in lunar exploration roadmaps, and try to bring those needs into EPFL and support and facilitate the conversation and the build-up of consortiums. And so the research and technology activities, technology development activities for those gaps to be bridged. And then go all the way to identifying flying opportunities with the labs and the different partners, so that we end up pursuing or accomplishing that goal of having our very own payload on the surface of the moon. And of course, something that we always do when in touch with our initiatives, we try to do this in a sustainable way. So we always look, we look always beyond just simply the mission, and we look at the life cycle of everything we do and the impact that it has. So this is just a brief summary. There will be probably an information session specific to the Lunar Initiative somewhat in a month or so. So I'll send an invite about that, and if you're interested, again, just get in contact. Happy to discuss always. So last year we also started conversations with the Moon Village Association. So the Moon Village Association is a non-governmental organization that what they're trying to do is to set up a global forum for every stakeholder involved in lunar activities. That could be government, industry, academia, or individuals in the general public, to stand up and speak about what needs to be done. So they do a lot of activities, mostly related, as I said before, with policy making, trying to set up the rules by which we should stand when we go to the moon to explore or to create our own businesses. And so we're members of the Moon Village Association. We're observers to this global expert group in sustainable lunar activities. And they contact us because they have this technical program that they created in 2019 called Payload Project. Although again, it was more of a program really than a project. And the idea for this Payload Project is to launch successive missions to the moon with different types of payloads. So basically, they want to set precedent with the first mission, but the idea is to launch multiple missions, bring different actors together, and try to set the basis for more missions to come in the future, basically launching different technology each time to the surface of the moon. And right now they're working on this first mission. And this first mission will consist on a lunar camera. So they want to launch a lunar camera to the moon to take pictures of Earth. And they contact us. Us at eSpace, together with the Advanced Quantum Architecture Lab at EPFL, we started talking with them about providing the sensor that this camera will need. And that's how the conversation started, just by talking about, well, there is a component inside this payload that we can provide. Of course, the MVA, being an NGO, they are trying to do this mission in a in-kind, with an in-kind approach, meaning there is no exchange of funds between the MVA and the people involved. So there's always the challenge of funding your own, finding your own funding for whatever you develop and provide to the moon. But they also give the opportunity for, in this case, us, fly free our own technology, which is not an opportunity that comes around very often. Launching something to the moon is in the order of 1.5 million per kilo, and now we have the opportunity of launching something free of charge. Only we have to spend or find the money to develop the technology, whatever it is that we need to do or that we want to do. So the main objective of this first mission, as I said, is that the Moon Village Association wants to recreate the overview effect. And the overview effect is simply this feeling of community and sense of communion that people share when they see Earth from space. So this is something that astronauts talk a lot about, that when they're in space and they look back at Earth, they feel like we are all part of the same spaceship, traveling in the universe, and that has a feeling that we should do more for planet Earth other than looking at ourselves or our own small community on Earth. So that's the overview effect. And the Moon Village Association wants to recreate this by having pictures and potentially video streamed from the lunar surface back to Earth. They also want to share whatever data we gathered, although this, I guess, is up to discussion. It depends on what type of experiments we end up performing there. And they also want to, as I said, set a precedent for future missions. So there's not just one mission, one-off mission that they want to do. What they want is to create a methodology by which more missions could come and more opportunities will come. So I think it's a great opportunity if we could be part of the very first one that they're aiming to or attempting to launch. So so far, coming from the Moon Village Association, the requirements are very vague, and as you can see, the mission objective is quite straightforward. So they have some requirements, but obviously all this is up to discussion in terms of the resolution for the camera and so on. So as I said initially, our first conversation were related to providing the camera sensor, but after discussing with them, we realized that it could be even better if we could provide the full payload. So if we can just develop in-house at EPFL a lunar camera and send that to be integrated in the lander and launched to space. So that's why you're here today. That's why I'm doing this today, because I want more people from EPFL to get involved if you're interested. And the good thing is that since we're acting as payload developers, we basically have I'm going to come back to this later, but actually, do I have this science? Yes, I'm going to talk about this, and then I will come back to the technical aspects. We have the opportunity to conduct our own research and our own scientific experiments beyond what the MVA wants. So beyond taking images of Earth, there is more that we can do, and we can tailor the design of this camera based on whatever experiments we want. And that's my objective here today, and what I've been doing for the last few days, and I will be doing for the next weeks or months, is to get back to professors and people at EPFL that are interested in being part of this. And maybe there is something that we can do that this camera can be used for that is interesting for your line of research. So we come up with major themes already that we think that are interesting and that could be done without changing too much the design of the camera. And that's Earth observation. So, having a global view of Earth from the lunar surface is a position that not so often we have with Earth observation satellites in Earth orbit. So that could be a very interesting approach, and also very interesting in terms of fundraising, since I just got to learn that the new ESA Director General is quite interested in this topic, and we've seen that with Horizon Europe calls that I don't know, 50% of them are Earth observation related. But there is more we can do in terms of terrain relative navigation, so we can point the camera down to the surface and try to get pictures and be more precise in the landing. We can do some type of environmental characterization. We can look at material science, or more generally, topographic studies or geology studies on the surface in a local scale. So if you have ideas, if this lights up an idea in your mind and you want to discuss it, don't hesitate to get in contact. As I said, so far the technical requirements for the camera are quite open. We don't know yet what lander will be used. We don't know yet what launcher will be used. So my approach is to set up the baseline of requirements based on our own interest and our scientific interest, and then iterate with the MVA whether that will be possible or not. And this is basically what we have so far. So what you see on the right side is just a visual concept that was provided by the MVA. It doesn't necessarily have to look this way, but this is what it was provided, and a small system architecture with 2 main units, an optical unit and an interface unit on the left side. But again, this is all up for discussion. there are major things that still need to be discussed, like whether or not we will need our own power system, whether or not we'll need our own thermal control system, active thermal control system. But if you're working on that and you're interested, there's always discussing to be had. So just get in contact and we will talk about it. And now I will leave the floor to Mingle, who will talk a bit more about one of the systems that definitely will go in this camera, which is the sensor. Mingle, I don't know if you have a presentation that you want to share, so I can stop.
Yes, I can share my screens. Thank you. So hello everyone. So today I'll be talking about the camera we have been developing, and to explain to you why we think it would be interesting to have this camera on the moon, and also what kind of applications we have been exploring. So just a quick introduction on the camera. The sensor is what we use is single-photon avalanche diode, or SPAD. So SPAD, as its name infers, it's a diode and it's sensitive to single photons. Single photon is the quanta of light, which means in a very low light environment, we can also get the signal from the photon, and this photon will create an avalanche and give us an electrical signal to be read out. So this is the current prototype of the camera, and we have been using this camera for a lot of experiments. As a camera, it can be used to take 2D images. Right now, we're trying to develop the RGB filters, but before we only have black and white images. So as you can see, we can take high resolution picture with this camera. One interesting point about the camera is that we also explored the dynamic range of the camera, which means that we cannot even just take picture in a low light environment. We can also take pictures in a very high illuminated environment. So we can expose the camera in a certain way that the image will not be saturated. So here's an example of 2D high dynamic range image. We also use the camera to do 3D imaging. So how it works is that we have a light source, and so you can see my laser point. We have a light source, which is a pulsed laser. And after the laser is pulsed, we open the camera for a certain short gate windows. In this way, we can detect the photon or the light reflecting from the object within a certain time frame. So that means with this time frame, we can get the distance of the object that we are illuminating by the laser. So we demonstrate 3D imaging, as you can see on the top. We also demonstrate 3D multi-object detection. So by placing more objects, transparent objects between the camera and the object, we can also observe the transparent plastic plates that we placed. So this gives us the information of the depth of the scene. We also use the same camera with the same gating function to observe some biological samples. So fluorescence lifetime imaging is measuring the fluorescence lifetime of the sample, which means by measuring the lifetime, we can know exactly what's the sample that we are measuring, and this gives us some insight about the biological the sample. So yes, this is another example of 3D imaging. And last but not least, we have 4D imaging that we demonstrate early this year. So how can I play the... So with this camera, again, with the gating gating function, we observe laser pulse in flight. And this is this was not done before. It's because this can only be the light path in flight can only be reconstructed with a certain amount of the camera resolution. And with this high resolution camera, we were able to reconstruct the laser pulse in flight. And this also gave us some freedom of exploring new applications with this discovery. So that will end my presentation. I will be happy if you have any questions.
Thank you, Minglo. Thanks a lot. I figured out how to listen to you. Somehow when I changed this sound input for you to listen to the video, it just blocks the sound from my side, but it's all good now. So yeah, at the end we'll have enough time also for the Q&A, but if someone has a question now, feel free to raise your hand or just speak up and or post it in the chat. I can also ask it to Minglo if you have a question. So yeah, again, thanks a lot. So this is one of the things that we will definitely have on board this payload. So now I'm going to come back to share my presentation. Okay. Here we go. So most of the other subsystems are again open for discussion, and it would be interesting if more people at EPFL get involved with us and help us define and design and develop the other subsystems that will be needed. Again, I'm not going to come back on this, but if you have an idea that I may not have covered today in terms of what can be done with such a camera, please get in contact. And there's still the discussions are still ongoing, so there's still time for you to suggest your own experiment, and hopefully we will be able to make it happen and fly to the moon. In terms of next steps of what happens now. In the upcoming days and weeks, I'll finalize building the EPFL team. So the people, professors, labs involved in this project. Together, we will finally, or more specifically, define the scientific use case or use cases for the camera. So what, beyond taking images of Earth and fulfilling MVA's objective of reenacting the overview effect, what else are we going to do and how we're going to use that data? So that will be defined quite soon, because it's a key component that will be needed when we start fundraising for the development of this camera and the performance of these experiments. Then I'll work together with the MVA and obviously with the people involved in our team to iterate and first define a baseline of what this payload, what this camera may look like. And what is needed based on the scientific use cases that we define, what its architecture looks like, and so on. And this will be iterated with the MVA. Hopefully soon they will be able to provide more details on which lander we're going to use in terms of also of timeline. How much time do we have to get it properly verified and flight proven if it needs to be. So all those things, all those details that are key for us to start working seriously on this project. I hope that we will get more information soon. Also, based on the level of interest from EPFL, if not all, so if there are some tasks that may not be covered by EPFL labs, then we would look outside EPFL and try to find some partners to work with to develop those different components. And obviously we will start the fundraising activities and conversations quite soon. I know that the MVA is precisely there to help us with that. So that's one of the reasons why I think this project is a great opportunity for us. It will be the flagship project of our new Lunar initiative, and it could be a great opportunity for EPFL as a whole to get on board and have a scientific instrument that is sent to the moon, which is something that, at least to me, it's is one of the reasons why I get up every day. So if you're interested, you want to learn more, you have here all the links. So just the new website that we have for the Lunar Initiative, if you want to learn more about the Moon Village Association, or if you want to read about what the mission looks like more on your own time, you have the link here. You can also send me an email and I can send you all this information. So with that being said, thank you very much for attending this information session. And now if you have questions, if you want to discuss about any topics, please feel free to do so. And yeah, thank you again. I don't know if anyone has anything to say. If not, then maybe we can close it here. And again, my email, you have it at the bottom of the slide. If you feel more comfortable sending me an email, then do that. Yeah, and thank you again. And I'll see you next time. Bye-bye, everyone. Thank you.
Thank you, David. Bye-bye.
Thank you for being here.
Thank you very much.